All right. Well, hey everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, April 18th, 2014. And we've got a very special event today, which is that we're going to try and break in the middle of the show and watch the SpaceX launch. Check this out. Hold on.
Should be at T20 right now, I think.
Yeah, right over here. I got it going in the background. Boom. So to all of the foreign news agencies are going to claim copyright on that clip of NASA television. I just want to say in advance, to hell with you. I will fight you to the bitter end because it's free NASA feed. Anyway,
you don't own NASA TV.
NASA
government
free. All right, so
I want my NASA TV.
joining me this week, we got Sandy Springman at Arecibo Observatory. Hey, Sandy. Are you muted?
No, I'm not. Hello.
No, you're not.
Hi. I'm actually at home today, but Arecibo Observatory is 20 minutes that way.
Right. Could have just kept the lie going. Fine. We got Brian Coberline. Hey, Brian.
Hi. How you doing?
Good. Casey Dreyer from the Planetary Society. Hey, Casey.
Hey, how's it going? Unlike Sandy, I am actually in Arecibo Observatory.
Right, yeah, we all are. We're all in the Arecibo Observatory today. Dave Dickinson at the Arecibo Observatory in Tampa, Florida.
Actually, I'm 100 miles west of the launch, so only with the cloud cover here, I won't see it. So.
Oh, really? Would you be able to see it?
I would if the skies were crystal clear. Mid-afternoon usually it's not the case, but night launches you can see from here really well. Daytime launches sometimes. It depends on the launch angle. This one's going to the ISS, so it's going to have that headed to the northeast kind of angle, so I probably would be able to see it if it was clear.
Got Jason Major. Hey, Jason.
Hey there. I'm home as well, and the Arecibo Observatory is about 280 minutes that way. So.
Yeah. Well, I am also at the Arecibo Observatory. See, oh man, we just. We have too much fun here. All right, so this week we're going to talk about the SpaceX launch, whether or not it was successful. We will know in real time, but we'll also see a test of the Falcon 9R with legs, and we'll show you that, which was a total success. We're going to talk about, of course, the discovery of a second Earth. Or was the discovery of a second Earth?
Is it?
We've got some funding issues for Opportunity and NASA. I wonder who's going to talk about that. We've got some problems with the Bicep 2 inflation results, CERN discovery of exotic particles, some pictures, I think, of the lunar eclipse, hopefully, the upcoming Lyriad meteor shower, and the Laddie impact. Farewell, Laddie. So, well, let's start with the big news, and let's just keep the timing going on here in the background. Oh, right, and before we get started, you can, of course, always communicate and talk to us. The way to do that is to use the Q&A app, which you should be able to see. If you're watching this video anywhere, it says that we're interacting with the public. Click that, and you can see the Q&A app. You can ask your questions, and I will try to remember to fire these off to the... to everyone. Oh yeah, and that new moons. Elad Avron recommended that too. You worked on that, Jason, so you probably can talk intelligently about that, right?
The
new moon of Saturn.
Oh yeah. All right, I can. Yeah, I can go.
Okay. That. All right. We'll just try to remember to add that.
Sure.
Okay. Cool. So let's just start with the big news, which is the discovery of another Earth. So I don't know if anybody knows this, but I hate embargoes. Absolutely hate them, and Universe Today is an embargo-free place. So I was as surprised as everybody on what the Kepler announcement was going to be. I was assuming it was going to be just like, hey, Kepler's doing great, we're able to get more data, but in fact it was like, oh, and here we've discovered the Holy Grail. So who worked on this one?
Mate.
All right, well then why don't you bring us up to speed on what was discovered?
Yeah, I mean, it was, every now and then the Kepler mission team comes out with a press announcement, and everyone wonders, oh, what is it? What is it? The last time it was, they just doubled all of the exoplanets that they confirmed. So now, they're up to, over 700, almost 800 of these things. But yesterday's news
on one day. They had
literally one day. Oh, by the way, double that. Yesterday's news was that the Kepler mission team has confirmed the first rocky, Earth-sized exoplanet in the habitable zone of its host star. And if that's not the holy grail of what they've been looking for, other than finding it, covered in alien cars and planes and jellyfish, I don't know what it is. This is the first time. Go ahead.
This is it. I mean, this is what we've been predicting this. We've been saying it's just a matter of time. It's in the Kepler data.
Right.
Here it comes.
And 5 years of Kepler looking at the same patch of night sky has led up to this moment where we have finally located the Earth-sized rocky world that could, not saying it does, but could very well have water on its surface if the atmospheric conditions are right. If a lot of conditions are right, but it's in the right spot. The planet orbits the star. It's a red dwarf. Named Kepler 186. It's located a little over 490 light years from Earth. It's in the constellation Cygnus, which is basically where Kepler looks. It always just stares at that one patch of sky. And unlike our G-type star, Sun, this is an M dwarf, so it's a red dwarf. It's smaller, it's cooler than our sun. As a result, the habitable zone is much, much closer in. So the planet, Kepler 186f, is the 5th planet discovered so far in the 186 system, and its orbit is just around where the orbit of Mercury would be in our solar system. So it's pretty tight in there, but its habitable zone is because it's that close into a much cooler star. We don't know the mass of this planet. We don't particularly know exactly what it's made of, but its size is just over 1 Earth diameter. I think it's 1.1 Earth diameters, and it orbits in a 130-day year. I mean, that's kind of all we know at this moment, but it's the habitable part that's really important. Liquid water, if it's there, could exist on its surface. We could have rain, lakes, streams, rivers filled with Kepler 186 Epheian fish and whatever. This is the important stuff.
Speaking of rain, then I would like someone to rain on the parade. I'm gonna. Who would like to sort of take some of the excitement out of this?
Well, it sounded to me like
sounds like Brian's job. Yeah, Brian. How should we not get super excited about this?
How should you not get excited about this? Okay, this is anything I say is not to belittle this discovery, which is actually a big discovery. This is a big deal. Okay, couple of reasons to be cautious. One is it's orbiting a red dwarf. Red dwarfs tend to have larger solar flares. They tend to have large solar wind. That would tend to make these planets dry. So you'd have to have a strong magnetic field to resist that. We know that this is an active star. We know it has star spots, for example, because in the same Kepler data we can see that. The other thing is these planets tend to be tidally locked because they're so close. This one is far enough out that it might not be tidally locked, but the close ones, they tend to be tidally locked. So if you just go by the statistics, it is more likely to be more Mars-like than Earth-like. However, it is still not a gas planet. It's not a super Earth. It is an Earth in a habitable temperature zone. So the possibility of water is there. It would still have to have a strong magnetic field. We don't know anything about it. We don't know what its mass is. But we know it probably doesn't have a thick hydrogen atmosphere given where it is too. So it's the right size, it's the right distance, wrong star, not Earth-like in that sense.
Now, Sandy, I know that, the discovery of a, Earth-sized planet in the habitable zone, it's not surprising that it was found around one of these M-class stars, right? Because they're the ones that, it's going to go around more rapidly, and so it's going to be seen more often. Is that right? You're muted. Oh, good.
It's been a long time since I've been in the exoplanet business, so I can't give you a really good answer for that. But I can tell you, though, that some people are saying, oh, this is Earth 2.0, it's in a habitable zone. But like Brian was saying earlier, Mars is technically in our habitable zone around the sun. Venus is technically in the habitable zone, and as far as we know, there's not a lot of life on either of those ones. So habitable in this case means it could support life as we know it, but we have no idea if it actually supports life or not.
So, and a good question here from Rich Hayward, and I think this is great. So, I mean, it's far away. It's close to 500 light years away. Do we have any kind of technology, any kind of technique that would allow us to do any kind of follow-up observations to try and get a sense of its atmosphere, whether it really is a blasted hellscape or...
That's going to come. Unfortunately, Kepler can only look at these planets. They can only detect these planets. Right. The ability to look into their atmospheres, that's going to be further missions. Like the James Webb Space Telescope. Obviously, 186F is going to be right at the top of the list of exoplanets to take a look at and figure out what's going on in its atmosphere.
There is a technique to do it. If you have a transiting planet, what you can do is you can look at the spectrum as the planet passes in front of the star. When it does, the atmosphere hits first and then the planet. And then when it leaves, the planet leaves first and then the atmosphere. So you can look at the fringes of this dip. If you have a high enough resolution image, you can look at the fringes of this dip at different wavelengths, and you can get an idea of the spectrum that way.
But do we have an instrument that's capable of that resolution? You can use
Spitzer for that, and you can use Hubble for that, but it's harder to get time on Hubble than it is on Spitzer. And even though the Spitzer Space Telescope... Go ahead.
Oh, I was just going to say they have done this with some planets, but not they're the gassy planets.
Those are typically the gas giants, so that have a lot of atmosphere going on. I mean, even if Kepler 186F had an atmosphere that was, a few times what Earth has, would it be enough to detect using that method?
You bring up a good point, Sandy, because at a distance, I've said that before, is that Venus would look Earth-like if you were looking at it as an exoplanet from a distance, but I wouldn't build an interstellar arc and head there just yet.
I think we really need one of those star shade ideas, right? One of these coronagraphs that we can have.
The big sunflower?
Yeah, the big sunflower that's blocking the light.
Terrestrial Planet Finder.
Yes, the Terrestrial Planet Finder. Boy, wouldn't it be great if we had the Terrestrial Planet Finder right now? I wish we hadn't canceled that.
Well, one of the other important aspects of this particular discovery is finding that there are, obviously now we know, Earth-sized exoplanets around these M dwarf stars, because they're the most common stars in the galaxy. 70% of the stars in the Milky Way classify as these red dwarfs. So having an Earth-sized world around one of them just boosts the odds that there's a lot of these out there.
But isn't the thinking that these M dwarfs are, as you said, higher solar flares potentially, and the planets have to orbit very closely, that they're going to blast the atmosphere away, they're going to scorch the landscape, pretty much anything.
They are stable for a long period of time. That's one.
If you get past that initial phase, then you've got a trillion years of nice.
Yeah, so life could evolve. It has a long time to evolve. That's one check they have in their favor.
And one of the particular things about Kepler 186 is it happens to be a hot M dwarf. So it's brighter, it's hotter than maybe some of its other cousin stars of the same variety. So 186F can be a little further out.
Yeah. So, but I think this is going to be the first one. There's going to be a bunch more in that data. We're going to get a bunch more of these announcements. They're coming. They're going to come fast and furious. I predict.
One of the things that's really interesting is.
Go ahead, Brian.
One of the things that's really interesting is the Kepler data taking is done. This period of Kepler's data is done. So this is all data mining now. We're actually going back through the data to find these discoveries, which is, I think, important to keep in mind, is that once the mission is over, it's still not over.
But there's the potential of getting more data out of Kepler. What about using, say, the James Webb for doing some of these follow-up observations? Is it going to have the capabilities we need?
Yeah.
Okay.
Yeah.
Better than Spitzer. It's the next. Yes.
There's a lot of observatories that are coming out in which we're going to be able to get planetary data. I mean, Gaia, for example, is not specifically looking for planets, but because it looks at spectra in high resolution, we can use that Doppler variation to find planets.
So here's what's weird for me, is I don't feel as excited about this as I would think that I should be.
Shame on you, Fraser.
I know.
I mean,
Like,
no, I was
become
told about this in 2008, 2007 when I started taking classes on exoplanets that, yeah, this is going to happen. It'll happen in 5, 10 years. We're going to find an Earth-like planet in the habitable zone. And we found it! Science!
Yeah.
Predictions!
Yeah, but it's not quite there.
Were you expecting little green men, Fraser? Like,
Well, yes,
what
of
do you
course.
want?
No, I want it around a similar mass star as the sun, I guess.
I'm
These
worried that
red
it's
dwarfs,
gonna...
they freak me out. They just,
You watch too much British
with the
sci-fi.
flares and the and the holograms and the cats.
I'm worried. I'm worried it's going to be the next Water on Mars, Voyager leaving the solar system kind of story, because it seems like a lot of these exoplanet stories are kind of devolving into the Tatooine type exoplanet, the Earth-like exoplanet. I think the public.
Well,
Yeah.
it's funny. It's like it's how it's being picked up and spun not only by the people who are writing the science press releases, but also what the media wants to do. In fact, during yesterday's teleconference, the first questions that were coming in from reporters from various places around the world, literally, was, "Is there life?" I mean, that's what they want. They want to hear that. They want to run the headline with that. They want the lead to be, we find life. And if they're not getting that, they want to push it that direction. And
Jason, did you see the bit where somebody was claiming the artist's conception was photoshopped?
No.
I kid you not.
Fake. No, but seriously, I mean that and I think that it's great that people are excited about that and they want to think that way. But the problem is that it ends up lessening the actual impact of the discovery that has happened. This is huge. This is the first, our first exoplanet was discovered in 1994. Kepler launched in 2009, so it was literally just a month over 5 years ago. And here it is. I mean, there are hundreds and hundreds of confirmed exoplanets, thousands on the list waiting to be confirmed, and we now have our 21st, literally the 21st habitable world that's been identified. I mean, that's a lot happening in a short period of time. Literally, these things are falling out of the space closet.
To give you an example, the original Cosmos...
2-minute warning, guys.
Known planets.
I'm going to go to the SpaceX launch in 1 minute. So.
Okay.
Got it.
Go, Brian.
In the original Cosmos, when that aired, there were no known exoplanets. And now with the new one airing, we have over 1,400 confirmed exoplanets, including an Earth-sized one in a habitable zone. That's how far
1783
we've
this
come.
morning.
I'm just not feeling it. I don't know what it is. I'm just, maybe
You're
I've
living
been
in the
living in
future.
the future for so long that, maybe my heart's been broken so many times. No, this is good. I'll be all right. Okay, so why don't we set this up then, David? So what is the SpaceX launch that we're about to enjoy?
This is CRS-3 going to the ISS. It's launching 26 minutes behind the International Space Station. Interestingly, and there's a lot of interest on this on Twitter right now, UK may see this Dragon and SpaceX launch come overhead in about 20 minutes afterwards if it goes off, because it's just after sunset there right now. So I was talking to some people over there about seeing it. It's going to dock with the International Space Station on Sunday, April 20th at 11:14 Universal Time, 7:14 a.m. Eastern Daylight Time. And I was over there for the second launch. They're kind of cool to see. They're small, fast movers compared to the shuttle, but still kind of interesting to see. Yeah, it's weather. I think they said they were about 40% chance for go, and they're under the solar proton flux level, which there was some concern because there was an M-class flare earlier today, and I was like, I wonder if this is going to scrub this launch. And interestingly, the Russians have a ship out currently watching this launch too, out in the ocean. So they're kind of very Cold War type stuff going on. But there's been a news article this morning that came up that says every time SpaceX tries to do this launch, this ship comes up, and so they're definitely monitoring it for some reason.
Looks pretty cloudy over there.
It is, yeah. It's going to get worse too. So if they don't get off today, I got a feeling they're not going to get off. Ooh, looks like they're.
Here we go.
Oh, there.
Oh, I see smoke. Oh, they're moving. Very cool. Looks like they're shooting from across Banana Creek too, across the causeway. That's about where I was for the S2. Cool. I think it's the first time we got a live launch feed into the Space Hangout.
Yeah, I know. This is the first.
And if
Anyone
anybody,
wants to hate, it says NASA up in the upper right corner.
Yep.
Yeah.
It doesn't matter. I will get the takedown request.
if you live anywhere between 40 degrees latitude north and south, and you have an ISS pass, you may be able to see the Dragon. I've seen Dragon following the ISS. Right now, the passes favor 40 degrees north to 60 degrees north. That's why UK is interested to see this pass. But the northern US will have passes tonight too, and they don't dock for another 2 days. So you may see the Dragon capsule chasing the ISS here over the next few evenings. This payload usually generates 6 objects too. The Dragon S2, the S1 they're going to try to fly back today and land in the water. That ought to be interesting, and that'll probably be coming up here in an hour or so. The S2, the Dragon capsule, the 2 clamshell fairings, and the 2 solar panels. So there's a friend of mine on one of the launches. He saw all 6 objects after the first orbit come over, so they are visible.
All right, I think we're done.
And Jason, I think you wrote some about the payload. I know they're sending up some kind of salad bar to the ISS or something.
Yeah, the veggie, the Veg-01 veggie experiment, which has been in the works for a while, and it's kind of cool. It uses this expandable Teflon bellows to serve as basically like a greenhouse for a setup of little, plant packets where they can basically have like a miniature garden up on the space station, and they can grow all sorts of produce, salad, lettuce. I think they're going to start off with romaine lettuce, various things that are edibles, and they can have fresh produce up there eventually if this works out.
Robonaut 2 is getting his legs too, and that's another notable thing that's on board this one.
So does anybody question Elon Musk anymore? I sure don't hear that anymore.
It's
commercial crew, they do.
It's interesting to think the whole scenario going on with Russia, Crimea, Ukraine, and the ISS, and what's going on there with collaboration. It's an interesting what if SpaceX had the money thrown at it, how quickly could they get commercial crew up right now if we had to say, hey, we need to get our own access back to the International Space Station.
But isn't the Dragon human-rated anyway? I mean, they're ready to...
I think they could do it within 6 months to a year if they really had to. If they stepped it up. So
it was kind of built with human rating in mind, but there's a lot of steps they have to go through.
They'd still have to certify it. They'd still have to fly it and certify everything before they could do it.
Like separation.
People in it.
Look at that separation. I love the
cool.
the live view from the spacecraft perspective. This is pretty great.
Yeah, talking about the future, Fraser, here's your private cargo company launching to a football field-sized space station in orbit, and with live HD video the whole way. Not bad.
Well, we're commenting on it on an information network.
And we're commenting, yeah, exactly. And here we are all around the world
this
having a live conversation about it.
This sets up, they have to do a contingency spacewalk too. Elizabeth Howell's been covering this more than I have, but I believe they're going to do it on the 22nd. I'm doing that without looking at any information, but I'm pretty certain that it's they're having some kind of, I think it's some kind of
backup computer.
It's a backup computer that needs to be fixed. It's 3 bolts apparently. It'll be an easy spacewalk, but it's an emergency spacewalk.
Yeah.
So you kind of want to get this done sooner rather than later. I think if it had launched earlier this week, they would have done the repair on Sunday, but I think the spacewalk is now on Wednesday.
They kind of had to shoehorn the space repair between the Dragon launch and the next Progress launch, I believe. So it's So now that's all going to happen.
The interesting thing here too is that after the separation, we know that right around now, or in the next 10 minutes, the first stage is going to try to fire its rocket again and deploy its little landing legs to test the whole reusability concept of the first stage of the Falcon. And I know that SpaceX has said that they have about they think a 30% chance of this working, but they're trying to develop this whole reusability factor of their rockets. So this is all happening right now. I very much doubt we'll see a live feed of that, but that's something to pay attention to.
Yeah, and if anybody's in UK right now, it's on its way. So in about 15 minutes, if your skies are clear, you may see this come up overhead. So they used to see the shuttle and the external tank after separation like come overhead as a pair right over the UK, and it's on that same orbital track right now after the ISS. So it is going to come right up over UK at sunset right now.
This just feels like we're CNN, doesn't it? Or like better. Like we are like live coverage. With
CNN will barely give this a soundbite though. So
yeah, no, I know. So yeah, no, obviously they won't.
If it were CNN, we'd have to go to the
it.
plane now.
But we are, we are providing live, intelligent commentary on a space launch. With
I love how that engine shroud heats up like that.
Yeah.
That's
I wonder if that was on purpose just to make it look cool.
It's really
let's run
LEDs.
with that. Let's make it glow orange. That's the kind of stuff they can do. One thing I did want to say is that I think this was actually a very, very important launch for SpaceX because they have this whole commercial crew thing has been coming up again with this tensions with Russia, and Congress has generally been quite hesitant about commercial crew because it kind of undercuts a lot of the institutionalized jobs and funding and all the other stuff that goes into classic NASA rocket construction.
Can you talk about that, Casey? Because we've while we're enjoying this launch, do you want to talk a bit about what's going on with the NASA funding?
Sure. Yeah, and so the commercial crew stuff again. This is really interesting because every year for the last 4 years, the Obama administration has requested a lot more money than Congress has given to commercial crew. Originally, they wanted to have 4 competitors. They're down to like 2.5 right now, and then they might need to down select to 1. They really want to keep 2 for competition. The 2 major players, of course, are SpaceX and then Boeing with their kind of low-cost commercial crew vehicle. So we have this whole context now of mixed in with this Russian tensions in Crimea and saying, right now, obviously, we're just launching off of the Soyuz rocket. And if the Obama administration, NASA administrator claims that if they'd gotten full funding since the beginning, we'd be launching commercial crew next year, and this wouldn't really be an issue. Instead, we're looking at the earliest, maybe 2017. And so the big problem is then, so Congress is saying, all right, maybe we really do need to fund commercial crew to get U.S. astronauts, kind of independently having access to space. And my feeling was that this launch that we've seen today has been delayed multiple times. There were leaks in the SpaceX first stage. There was also kind of a contamination issue with one of the other shrouds in the rocket. And if this hadn't gone well, this would have very much gone into the politics of saying that commercial crew is not going to be a safe option. SpaceX can't be really dependent and so forth and so on. And so the fact that we're seeing at least a successful launch to this point really helps bolster the argument for commercial crew as a viable and safe way to launch astronauts. And I think Elon Musk is going to be breathing a lot easier today. That's my take on this. And then I can talk about larger NASA budget issues here as we're watching.
Yeah, that's what I was figuring. Yeah, go ahead and continue on that conversation.
So this is all in the context of NASA's been proposed to be cut again this year by about $200 million. We had a senator who's kind of the most powerful senator on the U.S. Appropriations Committee saying NASA will get at least what it got last year. So we feel pretty good that NASA will at least maintain what it had last year, which isn't a great number, but it's not a catastrophic number either. And the big question, again, is going to be how much is commercial crew going to get this year in the context of the Russian situation? So that's going to be a big player. They had a lot of questions from Congress has been meeting the last few weeks about SLS funding and Orion funding. You've had questions from Congress about planetary science funding, which is seeing a cut again. And it's one of those things where the Senate will be meeting next week, and that'll kind of be their little view into what the Senate sees as the major problems with the president's proposal. Already you've seen, again, the lead person on the Senate, Barbara Mikulski, say, we really consider the president's budget as advisory, which means, we'll we'll take here and there, and then we'll kind of do our own thing with it. So we'll kind of read the tea leaves next 2 weeks after, I think May 2nd is when they meet. And so this process is continuing. The House has met. Senate will meet next month, and then they'll kind of each have their own versions of what they'd like to spend on NASA over the summer. They'll take a big break during the summer and campaign since it's election season here in the House and Senate. And then we'll have some kind of ideally some kind of budget agreed upon before October 1st. No one really knows if they're going to be able to pull that off, but they're actually trying relatively hard to do it, mainly I think to show voters that, hey, look, Congress can work. So we'll see how that goes. Within the larger context then, something that I've been talking about a lot at the Planetary Society, and something that's actually been getting a decent amount of press in the LA Times, New York Times, NPR, is, you know, if you take NASA's budget, you know, $17.5 billion or so, and you break it down into all the little, there's the Falcon, the Dragon separation there happening right now. I don't know if everyone can see that.
Yeah.
Oh, beautiful.
So cool.
Man, they've had good coverage. You know, in the past they've dropped out their satellite data relay coverage a variety of times. I think this has been smooth almost the entire time.
There were some CubeSat
There's a couple of glitches that I saw, yeah.
Yeah.
There's
What's that?
I think a project called KickSat that's getting
That's right.
jettisoned off.
Are those some of the additional satellites there, just in the
Yes.
bottom there?
No, I think those are just like fragments or ice or something like that. But there are some CubeSat payloads on this.
We're living in the future.
I know. I know.
So let me just jump back to Opportunity while we have this nice background to look at. So Opportunity, of course, has been on Mars for 10 years now. Then he also has we have a satellite around the moon called the Lunar Reconnaissance Orbiter. Both of those missions, kind of surprisingly and kind of tucked out of the way here, were zeroed out in next year's NASA budget. So basically implying, you know, if Congress doesn't do anything, we switch off Opportunity around September 30th, and we crash Lunar Reconnaissance Orbiter into the moon maybe a month or two before. And that's kind of caused quite a bit of people being upset because, you know, these are functioning missions. We've spent a lot of money to get these to where they are. They're still doing great science. Why are we turning these off? And I published this article on the Planetary Society. I believe, Fraser, you'll link to this throughout the video. But the big problem is that, you know, we're actually suffering from a burden of success at NASA. Last decade, NASA launched about a dozen spacecraft. Kepler was one of those in their planetary missions. And it costs money to run these missions, anywhere from a few $1 million for Messenger to $60 million for Cassini around Saturn. And if you add all of these up, it actually represents about a quarter to a fifth of NASA's entire budget for its planetary exploration program. So as the budget for planetary has been cut, you've kind of run up against this minimum level just to keep your existing missions functioning, and you start running out of room. Where are you going to cut? And so the administration is saying, yeah, let's get rid of these older missions so we can start pursuing new missions. And that's an argument to be made for that, but then there's also the argument to be made for when are we going to have a rover on Mars again looking at these clay deposits around Endeavour Crater? Probably never within our lifetimes. And so we're trying really hard to make sure that those, basically saying, let's take the third option, which is just give more money to planetary exploration, then you don't have to make this issue. So that's one of the major things going on right now within NASA, which is, and you're having the same problem in astrophysics where they canceled the Sophia observatory just as it kind of hit its stride. They still don't even have enough money to operate all the missions from Hubble to Spitzer to Kepler to anything. So they're going to have to make some hard choices there too. Or, as we generally advocate, just give them a little more money and let these things keep running.
Casey, that was a great article too, by the way. I read that a couple days ago.
Thanks.
That was really, really informative and I like the idea of that strange punishment for success, you know, that happens. You know, these missions have been more than successful and are in extended missions now, and upon extended missions, and then they're going to be shut off, which makes absolutely no sense at all from a scientific perspective, because, you know, they are gathering data like we've never had before. Opportunities are going on 10 years.
Yeah, 10 years.
We've got a bunch of stories to get through, and you know, as always, I've offered Casey Canada. We'd be glad to take over operation of your missions. Anything you want to drop, we'll pick them up. Just let us know.
I'll pass that along.
So, Sondi, I'm going to set up your SpaceX landing video, so maybe you can talk over this one here in a second.
So we've talked a lot about SpaceX today, so let's just continue with the launch theme. So this is a Falcon 9 test launch that went up to 250 meters, which is about 820 feet for those of us who don't use the metric system. So to give you a sense of scale, that's not quite as high as the Arecibo dish is wide. And you can actually see a bunch of cows chilling off in the lower left of the video.
They're about to freak out.
So this is Texas, I think this is happening. And so this footage is absolutely amazing. This comes from what Jeff Faust on Twitter told me is a hexacopter. So I'm not sure, I'm pretty sure this is some sort of uncrewed vehicle that someone is remotely controlling, watching this thing go up with its legs extended. And then it goes up, it goes up, it goes up. Somewhere in this cow field in Texas. The space age is here, and it's been certified by a bunch of bovines.
They actually test these out just outside of Waco, which is just a couple hours south of Dallas.
Yeah.
Tesla also tests their batteries out there, so that if they blow up, you only have to flip burgers. Sorry. So then this thing lands. It's amazing.
Cows
My
always make
SpaceX
videos.
buddy has
we've
this in
shown this
his-
off before, right? This is very similar to the Grasshopper launch, but
Right, but
that's
this happened a lot more quickly, and it lands on its legs, and it goes up to 250 meters.
And so that's a bit of a sneak preview of what this, I guess, of what this launch is going to be, or the landing theoretically that the Falcon 9 is going to attempt to, land or hover above the water at the end of that first stage, and then it's going to drop into the ocean. So this is
Right.
This is
It will
serious.
be reusable. This is stepping stones to Mars, folks. You got to make sure that your rockets can be used again and again and again.
Dave Dickinson, take the wind out of our sails.
Take the wind out of
As
my
far as
microphone.
as far as the SpaceX launches,
Well, the reusability landing.
the reusability. Yeah, it's I certainly hope they pioneer that and they actually make that work. I don't know how financially sound that's going to be. I mean, they tried to do it with the shuttle, and it took like an army of engineers to rework and refurbish that. And I know the shuttle had kind of its own special problems of its own with the SRBs and things like that. But I don't know. I'm kind of a wait and see as far as the total reusability of the system. It will be cost effective versus just throwing things away.
So
I hope it works.
you're concerned that that even if they are able to make these first stages, take off and land again, and even maybe the second stages, that at the end of the day, all of the refurbishment that's going to have to go in to get them flight ready again, they might as well just throw them in the garbage and build new ones.
We'll see. We'll see. Like I said, I hope it does work, but I'm kind of a wait and see with that whole program.
Get with the program, David. This is the future. All right.
I hope it works.
Yeah, because that would change everything. So that would be great. All right, Brian. So Brian, we talked about the inflation results in the Bicep 2 experiment and how that was evidence of inflation in the cosmic microwave background radiation. Everybody cheered, Nobel Prizes all around. But wait, there's a problem, maybe?
There may be a problem. This is a new paper out that was looking at other possible sources for this polarization. Basically, if you remember, the evidence for inflation comes from polarization of the cosmic microwave background light, specifically what's known as B-mode polarization. So you're getting microwave radiation and it's polarized, and the pattern of that tells you about inflation. So this new paper looked at something that are called radio loops. And basically, you've got these large magnetic fields, galactic-sized magnetic fields. And we've known about these for a long time. There's nothing new about this. And when you have a magnetic field, when you have charges moving in a magnetic field, what happens is they tend to spiral along the magnetic field line because of the way the magnetic force works on charges. So if you have plasma within an area that there's a magnetic field, the charges, the ions, will spiral along the magnetic field, and they will produce what's called synchrotron radiation. So they will create these radio waves as they're spiraling along this. This new one looks at, there's also the fact that there's dust in these areas, and the dust, when it can get a charge on it, can spiral and create microwaves, not just radio waves. And so what happens is, if there's dust there and it's creating this microwave radiation, it can look like B-mode radiation. So it can look like this inflationary signal.
So how far away would this dust be from Earth then?
This would be in our galaxy. So
Right.
these are from radio loops within our galaxy. So the question is, the term they use is foreground versus source. So the idea of the foreground, because the cosmic microwave background has to come through everything, so it gets distorted as it goes through all the stuff to get to us. And that's part of the reason why B mode is so hard, is that there's two ways to do it. One is you can get it from gravitational lensing, from the original cosmic microwave background can be gravitationally lensed, and that can give you B mode. And then it can be due to inflation, and that can be B mode. And now it can be from dust within these radial loops that are creating microwave radiation. They're actually emitting that, and that can look like B mode radiation. So the question is, in the original BICEP 2 paper, you have to eliminate kind of all the foreground sources. You have to eliminate all the sources, and they eliminated a whole bunch of sources. They didn't take into account the radial loops, and that's
so
what this new paper
is there
takes.
a way that they could do that now? I mean, can they go back and take a look?
They can go back and they can look at this and see if there's still a difference. So it doesn't necessarily kill the BICEP 2 results, but it shows a critical weakness, which is BICEP 2 looked at one wavelength. So they look at one specific wavelength range within the cosmic microwave background, and they're looking at one specific area where there are radial loops. And so it is, at this point, hard to see if there is truly an inflationary signal or if this is due to these radial loops. And we don't know at this point. They're pointing out that this could be a problem, this is an issue. Now it's back in BICEP 2's court.
Right.
Is there some sort of a way that they can use, like a cosmic adaptive optics type way to cancel that out and really see what's going on from these really distant sources?
Well, this is actually what makes it really difficult, because what you have to do is you have to identify all of the foreground sources. So it's kind of like looking at an image through distorted glass. And if you map the shape of the glass, you can then understand how that distortion occurs, and you can get an original image. But you have to take everything into account, and this is where it's difficult, because if you miss something, then what you think is real is actually a foreground effect or something. So nobody was thinking that these radial loops would create microwaves of an area that would look like B mode radiation. I mean, they're called radial loops because most of the signal that comes out of them really are radio waves. And so this new paper is looking at it that no, the dust, charged dust can have this radiation signature that looks like polarized B mode radiation.
How plausible does that feel to you?
I think the big thing to keep in mind, BICEP 2 is kind of a tentative result. It's only a small area, it's one wavelength, and it's always been a tentative result. It has the advantage of being the first result, but we really need the larger data. The Planck data is going to be the big one. I mean, the Planck data is all sky, it's multi-wavelength, it's taking more time to do, but that's where it's going to be conclusive. That's where we're going to know whether this is or not. So, BICEP 2 has to go back and take this now into account and say, okay, is there still a difference? There may be, but right now we don't know.
Well, one thing we know for sure is that there was a lunar eclipse this week. And Dave Dickinson, you were all over that, warning us of the terrible fate that would befall humanity.
Yeah, it's funny.
Blood moons, the 4 blood moons.
Yeah, but there's 3 more, so the world.
There's 3 more. So when do I get my apocalypse? And how was the lunar eclipse for you?
That's actually a pretty smart ploy from the people that are trying to sell the Blood Moon DVDs at $19.95, because they got all of this year and next year to High Moon going on. So it's pretty smart.
Can I buy a Blood Moon DVD? Apocalypse.
I think it's John Hagee, or it's somebody that's promoting the whole gloom and doom on the lunar tetrad. But yes, there was a lunar eclipse, total lunar eclipse, first of 2014, first eclipse of any kind for this year. Tuesday morning. It was me and Astro-Katie and Scientific Scott Lewis. We were broadcasting it for Space Fans News. You were there for a little bit, Fraser, right?
I jumped in for a second, and then I hopped on an airplane, yeah.
Yeah, you were at the airport, yeah. But I was amazed again at how many people, this is kind of like the Mars Curiosity landing. I was amazed how many people were up at 2 or 3 in the morning to cover this, because at first I thought, Tuesday morning, it's a work day, it's a school day, there's not going to be many people. But I was really impressed, and it was one of the brighter eclipses that I had seen for a while. Probably not the brightest eclipse, but this one was it was red. The moon turned red. There was a nice. I've got one of my photo montages that I put together real quick because the first thing I did after I got done filming the eclipse, took about an hour nap, did a radio interview with a local radio station, and then turned around and wrote the article for Universe Today. I'm still seeing awesome photos coming in now.
Yeah.
Right now, there's a lot of people are doing some pretty awesome montages. And
yeah, some great time lapses. So there's you're going to be.
Yeah, I saw a time lapse video too that came out. That was pretty amazing that somebody did that. This is one of the longest ones we've got until 2018. And there's another one in October 8th. The circumstances for the East Coast aren't quite as good. We nearly got clouded out here. I thought we were going to. A lot of the U.S. East Coast got clouded out, yes. Just north of us, I think the dividing line, Richard Hay up in Jacksonville, Florida, got a view of it. I think the dividing line was just north of him. And then everybody east of the Mississippi totally missed out on this one. But there's another one coming October 8th. And then there's another one next year in April, and another one in October. So there's more chances. North America gets all 4 of these eclipses too. So
this was my best view before it started raining.
Oh, I had a great view. As I said, I was on an airplane, just a quick airplane from Vancouver to Victoria, and then it was totally clouded over. And as I drove north along Vancouver Island, I guess around 2 in the morning or so, things got clear, and it was boom, just nearing the end of the sort of eclipse part and moving into the red zone.
Yeah,
and Mars was right beside it, and Spica was right there. It was fantastic.
Yeah, I got a lot of questions about what are those 2 stars next to it. Yeah, there was Spica and there was Mars, and there was 76 Virginis was very close to it too. Because a lot of the photos I got, I thought it was Spica, and then I took a closer look. I was like, no, that's too close. And there was 76 Virginis was actually occulted by the eclipsed moon from Hawaii. Now, I don't know if anybody caught it. I kind of sent a query out to see if anybody actually caught the occultation, but that would have been kind of neat to see too. So yeah, these are always kind of cool events.
And so what should people be looking in the sky next?
There's a Lyrid meteors coming up next Tuesday, and it's probably worth starting to watch this weekend. The bad news is that eclipsed moon now is going toward last quarter, so it's going to be in the morning sky as well, so that will probably wash out some of them. But the April Lyrids are usually worth watching for. The zenithal hourly rate, the maximum ideal rate for these are about 20 per hour. So that usually piques my interest. So probably Monday, Tuesday, any clear morning I get this coming week, I'll be out watching for them. If you know where the star Vega is, the radiant is very, very close to Vega, and it's going to be high in the sky right around 4 o'clock. If you're like 30, 40 degrees north latitude, it's going to be high in the sky about 4 a.m. or so. It's going to be the best time to watch for these. And the shower has put out some outbursts too. There have been, over the decades, once in a while we've got an outburst that's topped 100 per hour for the shower, so it's always worth kind of watching for
it. Simon M. just posted into the chat that he saw the dragon in the UK.
Oh, very cool. I have to.
Yeah.
My Twitter stream's probably erupting with photos. I'm just not looking at it right now.
Yeah, all of ours are. Yeah.
I'll see it once I get out of here and turn on probably.
David, is that Tuesday morning or Tuesday night?
Tuesday morning, April 22nd is the peak. Yes, and you know, looking at various sources, it's actually going to peak over 22nd and 23rd because I look at the American Meteor Society, I look at the Royal Astronomical Society calendar, and I look at Guy Outwell's almanac. All 3 of them have periods, peaks for the shower spanning about 24 hours. So that tells me that nobody really knows that this shower needs to be better studied. You see a wide disparity as far as when the actual peak is going to arrive versus what all these different almanacs and calendars are saying for predictions. So it's over a 24-hour span.
So one other thing that just happened just before we went live with this episode of the Weekly Space Hangout was the Laddie mission crashed into the moon. And Casey, I think you were covering this as well?
Yeah, I covered this a little bit.
Did you win the pool?
No, it actually crashed a few days earlier than even NASA science team was thinking. They had, in their press conference a few weeks ago, they were predicting April 21st, and lo and behold, this morning, 3 days early, it ended up smashing into the backside of the moon. So what happened was, this has actually is a nice kind of segue from the eclipse, because so Laddie, of course, was the small mission to look at the lunar dust environment. You know, I know. Stay in your seats for this one, but it's an important kind of scientific questions about the lunar dust environment and how it threatens landers and astronauts. And it also had this really cool laser communications device that you could actually beam basically like a fiber optic cable connecting the moon to the Earth, of course, without the cable. Huge data rates as a kind of a test concept for future missions in space, so that's very cool. But Laddie was always supposed to be a very short mission, about 3 months. It did so well, they had so much extra fuel, they extended it a whole extra month, which was up until around now. And because of that, they had never designed it to survive a lunar eclipse. So what happens with the lunar eclipse, of course, you're in your shadow, the temperature drops significantly since they're not in the sun anymore. And they were worried that their propulsion systems would actually freeze and they wouldn't be able to control their orbit anymore. And so what they actually did last week before the eclipse was to give one last final thruster firing to put it into the Laddie death spiral, where it would slowly eventually impact on the far side of the moon in order to kind of preserve any historic Apollo landing sites, but they didn't want to depend on propulsion working after the eclipse. But it survived the eclipse. They didn't need to do anything more, and Laddie, because of all of the little, bumps and collections of more mass and less mass on the surface of the moon, pulled it down a little faster than expected. So it was a planned deorbit of the mission, mainly to protect these historic sites on the close side of the moon. Laddie reached all of its science goals and did extra science, and we wish it well. It's done.
Casey, were
Thanks,
they taking any data during the eclipse? Do you know?
I
Was
don't know.
Laddie
I
actually-
assume they were. That would make sense. I think they took data all the way up until the end. It's kind of interesting. The only way they know it crashed, and this was their plan from the beginning, was just to, of course, they track it. It goes behind the moon. They can't track it anymore, and then they look for when it would pass out from behind the moon. And then, of course, when it didn't, then they know, well, it's done. And so then what they do is that they take the last trajectory data that they had from it, and they actually put it through some NASA supercomputer, and it takes about 12 hours. They can actually crunch out as much, they have these very detailed gravity maps of the moon now, thanks to Grail mission last year, and they can actually pinpoint pretty much within a few meters where they think it crashed on the backside of the moon based on the last known trajectory information. And within the next few weeks, NASA's Lunar Reconnaissance Orbiter, the one, by the way, that's zeroed out next year's budget, will try to eye its camera to where Laddie crashed and to see if they can see a small crater on the backside of the moon.
That's great.
That's cool.
Okay, well, why don't we wrap this up? So we'll give people a chance to shamelessly self-promote themselves and the things they're working on. So, Sandy, where can we find out more? The birds are chirping.
Sorry,
in
it's
the
Good Friday here, and everyone's driving their loud cars around, and the loudest car just left. I'm at Sandy on Twitter, and I wrote something for for the Planetary Society blog a couple weeks ago about how repairs to Arecibo Observatory have completed, and we're now back in business. So follow me on Twitter for coconuts, cats, and klystrons and other radar adventures.
Awesome. Brian Coberline.
You can find me on Twitter at Brian Coberline, and you can find me on my website at briancoberline.com, where I do daily posts, and also on Google Plus, where I do daily posts. So,
Is that also at Brian Coberline?
Google, it's google.com plus Brian Coberline.
I'm sensing a theme. That's good branding, Brian.
Yes.
Casey, where do we find out more?
Planetary.org, of course. I'm the Director of Advocacy here at the Society. And then also next week, for anyone in the DC area, I'm going to be at the Humans to Mars Summit. I will also be at the USA Science and Engineering Festival next weekend. So if you're in town, shoot me a text, or not a text, I guess, tweet at me, at Casey Dreyer on Twitter, at Explorer Planets is our main site, but just planetary.org points you to all the right places.
Dave Dickinson, have you slept yet?
Actually, I finally slept yesterday. Yes, yeah. It's
Good, okay.
I am Master
All
Guys with the Z. It is eclipse season, so yes, it was eclipses all eclipses all the time this week. And my next article is probably going to be on the next eclipse, which is central annular eclipse over Antarctica, but Australia will get to see it as a partial. So I'm writing up an article on that.
Right, you get those pairs, right? You get lunar, solar.
Yeah, it's always solar. Yeah. So the next one is a partial solar eclipse on April 29th.
Jason Major, where do I find out more?
I was born at lightsinthedark.com to my space life, and I've since migrated to Universe Today and Discovery Space News. I'm also on Twitter at JP Major, and I'm on Facebook and Google Plus as well. So all space, all the time.
Awesome. All right, and of course, I'm Fraser Cain. If you haven't already, subscribe to this YouTube channel so that you'll get these videos suggested to you on a regular basis. Also, if you want to see some of the other stuff we're working on, go to patreon.com/universetoday, and you can see all the other projects that we're working on and ways that you can get involved. So thanks, everyone, for participating as the panel. Thanks to everyone for watching. And I apologize in advance when this video gets taken down for copyright violation for us displaying NASA television.
This will be the lost episode.
This will be the lost episode. Yeah. People will have to just remember an oral tradition of what happened in this episode. I remember the days. All right. Well, thanks everyone, and we'll see you all next week. The impact. Farewell, laddie. So, well, let's start with the big news, and let's just keep the timing going on here in the background. Oh, right, and before we get started, you can, of course, always communicate and talk to us. The way to do that is to use the Q&A app, which you should be able to see. If you're watching this video anywhere, it says that we're interacting with the public. Click that, and you can see the Q&A app. You can ask your questions, and I will try to remember to fire these off to the to everyone. Oh, yeah, and that new moons. Elad Avron recommended that, too. You worked on that, Jason, so you probably can talk intelligently about that, right?
The
new moon of Saturn.
Oh yeah. All right. I can go over that.
All right. We'll just try to remember to add that.
Sure.
Okay. Cool. So let's just start with the big news, which is the discovery of another Earth. So I don't know if anybody knows this, but I hate embargoes. Absolutely hate them. And Universe Today is an embargo-free place. So I was as surprised as everybody on what the Kepler announcement was going to be. I was assuming it was going to be just like, hey, Kepler's doing great, we're able to get more data, but in fact it was like, oh, and here we've discovered the Holy Grail. So who worked on this one?
Mate.
All right, well then why don't you bring us up to speed on what was discovered?
Yeah, I mean it was every now and then the Kepler mission team comes out with a press announcement, and everyone wonders, oh, what is it? What is it? The last time it was, they just doubled all of the exoplanets that they confirmed. So now, they're up to over 700, almost 800 of these things. But yesterday's news
on one day. They had literally
one day. By the way, double that. Yesterday's news was that the Kepler mission team has confirmed the first rocky, Earth-sized exoplanet in the habitable zone of its host star. And now, if that's not the holy grail of what they've been doing,
all right, so
I want my NASA TV.
Joining me this week, we got Sandy Springman at Arecibo Observatory. Hey, Sandy. Are you muted?
No, I'm not. Hello.
No, you're not.
Hi. I'm actually at home today, but Arecibo Observatory is 20 minutes that way.
Right. Could have just kept the lie going. Fine. We got Brian Coberline. Hey, Brian.
Hi. How you doing?
Good. Casey Dreyer from the Planetary Society. Hey, Casey.
Hey, how's it going? Unlike Sandy, I am actually in Arecibo Observatory.
Right, yeah, we all are. We're all in the Arecibo Observatory today. Dave Dickinson at the Arecibo Observatory in Tampa, Florida.
Actually, I'm 100 miles west of the launch, so only with the cloud cover here, I won't see it. So.
Oh, really? Would you be able to see it?
I would if the skies were crystal clear. Mid-afternoon usually it's not the case, but night launches you can see from here really well. Daytime launches sometimes. It depends on the launch angle. This one's going to the ISS, so it's going to have that headed to the northeast kind of angle, so I probably would be able to see it if it was clear.
Got Jason Major. Hey, Jason.
Hey there. I'm home as well, and the Arecibo Observatory is about 280 minutes that way. So.
Yeah. Well, I am also at the Arecibo Observatory. See, oh man, we just. We have too much fun here. All right, so this week we're going to talk about the SpaceX launch, whether or not it was successful. We will know in real time, but we'll also see a test of the Falcon 9R with legs, and we'll show you that, which was a total success. We're going to talk about, of course, the discovery of a second Earth. Or was the discovery of a second Earth?
Is it?
We've got some funding issues for Opportunity and NASA. I wonder who's going to talk about that. We've got some problems with the Bicep 2 inflation results, CERN discovery of exotic particles, some pictures, I think, of the lunar eclipse, hopefully, the upcoming Lyriad meteor shower, and the lad. All right. Well, hey everyone, my name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, April 18th, 2014. And we've got a very special event today, which is that we're going to try and break in the middle of the show and watch the SpaceX launch. Check this out. Hold on.
Should be at T20 right now, I think.
Yeah, right over here. I got it going in the background. Boom. So to all of the foreign news agencies are going to claim copyright on that clip of NASA television. I just want to say in advance, to hell with you. I will fight you to the bitter end because it's free NASA feed. Anyway,
Don't own NASA TV.
NASA.
Yeah,